In this program, you'll create an LED light meter that uses the light sensor and the LED strip so that the less light that's on the light sensor, the more pixels will light up on the LED strip. Anytime we're using the LED strip, we want to include the ledstrip.h library. A code library gives your program access to special functions that are exclusive to the LED strip. For example, strip.clear, strip.setPixel, and strip.draw. To use the LED strip library, we need to give the LED strip a name. I've named mine strip because that's easy for me to type and easy to remember. We also need to complete the LED strip function here. It has 3 arguments. First, how many pixels are on our LED strip? Second, which pin of MakerBoard is plugged into the green wire of the LED strip? And third, which pin of the MakerBoard is plugged into the blue wire of the LED strip? Within the void setup function, use the pin mode function with arguments A2 and input to set up your light sensor. The light sensor is plugged into the smaller block of ports at the bottom of MakerBoard, and make sure the plus and minus signs on the light sensor board match up with the plus and minus ports on MakerBoard. Within the void loop, you're first going to create a variable. This variable is an integer type, shortened to int, and that means it can only have whole number values, no decimal places. Next, we'll name the variable, and I'm naming the variable pixel count, because that's what this variable is going to stand in for, the count of pixels that are lit up on the strip. After a single equals sign, we give the pixel count variable its starting value. This is an analog read from port A2, so it's going to take the light sensor value, which can range from 0 to 1023, and that's going to be the value of pixel count. On line 13, we're going to change the value of pixel count using the map function. The map function allows us to match up 2 different ranges of numbers, even if they are different sizes. It has 5 arguments. The first argument is what number are we mapping? We're mapping the value of the pixel count variable. The second argument is what is the lowest number from the range of values we're starting from. Here that's 0 because that's the lowest number that the light sensor can send into the code, and it will send in 0 when it's in almost complete darkness. The third argument is what is the highest value from the range of numbers we're starting with. That's 1023, which is the maximum value that the light sensor can send in when it's got a really bright light shining on it. The fourth argument is what is the value that we want to map the second argument to. In other words, when we have a reading on port A2 of 0, what do we want to translate that value to? Here we want to translate that value to 14, because the less light on the sensor, the more pixels should be lit. So a value of 0 coming into the light sensor should equal a value of 14 for pixels that are lit up. The fifth argument is what value do we want to map the third argument to? Again, this is a light sensor reading of 1023, and it's corresponding to a number of LED pixels, which is 0, because when we have a light value of 1023, we want to light up 0 pixels on the strip. After line 13 runs, pixel count will have a value ranging from 0 to 14. Line 16, the strip.clear function, clears off any LED pixels that are lit up. Next, we have a for loop. The for loop has 4 main parts. There's a variable that is given a name and a starting value. There's a condition that is checked every time the for loop tries to run. There's a change to the variable value that happens after the code between the curly braces runs. And there's the code between the curly braces that runs whenever the condition of the for loop is true. In this case, we're creating an integer variable named I that has a value of 0. The integer type means the variable can only have a whole number value, and I is a common name to use in for loops when you're just counting how many for loops have run. The condition here checks if I is less than pixel count. So on line 13, we set the pixel count variable to a value between 0 and 14. If I is less than whatever that value is, then the code between the curly braces runs, and I is increased by 1 with I++. After the setPixel function has run and the for loop is completed, the strip.draw function will display whatever pixels need to light up on the strip. Then the end of the void loop is reached here on line 24, and the code will jump back up and take a new reading from port A2 and map that reading from 0 to 1023 onto 0 to 14, clear off any values that are on the strip, and show the new number of pixels that should be shown. Let's imagine how this program might run. If the light sensor is seeing a medium amount of light, let's say 500, then pixel count is going to get set to 500 on line 12. On line 13, the map function is going to map 0 to 14 and 1023 to 0. It also maps all the values in between. So if we have a pixel count value of 500, that's going to get mapped to a value of 7, halfway up the LED strip. The strip.clear function clears off any LED pixels that are lit. And in the for loop, there's an I variable that's created and set to 0, and as long as I is less than 7, the code is going to run. 0 is less than 7, so the code inside the for loop will run, and that's a setPixel function. The setPixel function has two arguments. First, the pixel that we want to light up, and we're using I to determine that pixel. And second, a color value ranging from 0 to 299 that we want to display on the pixel I. So when I equals 0, the 0 pixel, or the one closest to the wires plugged into MakerBoard, is going to get turned on to a color value of 200. The closing curly brace of the for loop is reached, and then I++ will run, changing the value of I from 0 to 1. 1 is still less than 7, so the code between the curly braces will run again, and pixel 1 will get set to a value of 200. The for loop ends, I increases from 1 to 2. 2 is still less than 7, so the code between the curly braces runs, and pixel 2 gets set to a color value of 200. Eventually, I is going to equal 6, so pixel 6 will get set to a value of 200, the for loop will end, and I++ will move the value of I from 6 to 7. 7 is not less than 7, so the code inside the curly braces will not run, and the strip.draw function is going to display all those setPixel functions that we've been setting as the for loop's been running. So pixels 0, 1, 2, 3, 4, 5, and 6 will light up. The void loop will end on line 24, and the program is going to jump back to line 12 and take another reading. Now let's imagine you shined a flashlight on the light sensor. It's got a reading of 1023. So pixel count equals 1023 on line 12, and on line 13, you map that value from 1023 to 0. So we want 0 pixels on the LED strip to be lit. The strip.clear function clears off any pixels that were lit up on the strip from the last void loop. In the for loop, we have int I equals 0, and when the condition is checked, is 0 less than 0, that's false. So the strip.setPixel function isn't going to run at all. When the strip.draw function runs, it doesn't have any more pixels to light up, so it's just going to clear everything off. This means that the LED strip will be completely dark. No pixels will be lit up at all. So this void loop takes light readings, maps them, and then uses that mapped value to decide how many times to run the for loop. Every time this void loop runs, the entire strip is getting cleared, and then starting at 0, you start lighting up pixels one at a time until you reach the value that corresponds to how much light the light sensor sees.